Welcome, Mrs. Mahoney's podcast. This is our third in Unit 5 that we're talking about naming. Now today we're on page 13. I know we kind of skipped, and the reason we've skipped, decided we're going to keep anything that's pretty much the ionic relating to ionic together. We'll come back and we're going to do the covalent, but we're going to do that after the test. So we're going to name covalent after the test because I don't want to add anything confusion and start anything that won't be on the test. So reading into that, hopefully you read that yes, naming acids you could have some acids are going to be on that test that you have on Thursday. So the first thing you need to do is to recognize, how do I know if it's an acid? So a couple key things when I'm looking at if it's an acid, right here, acids have that hydrogen. And if we notice, it is held together by a covalent bond, but look at what it's producing. It's producing this ion, this hydrogen ion. So when hydrogen acts as the positive, we know it can act as a negative when it's with a metal, and we make a hydride compound. This time we're looking when hydrogen acts as a positive ion, and so then it means we need to partner it with a negative anion and look at the relationship. So how do I know if it's an acid? This is what you look for. It's not just does it have a hydrogen, it begins with hydrogen. That's what you need to know. Okay, so to recognize again, what are we looking for? It begins the compound. When I'm saying beginning, I'm talking about the compound. When you see a formula, begins with this H. That's the first element you're going to see. That's what's going to identify it as an acid. If I've given you the name, you're going to have the word acid in the name. That's going to be the easy one. It's when I give you just the compound and you have to write the name of it, that's when it gets a little bit trickier looking at that. So let's look at our three types of names. First one, let's look at a binary. And again, what does binary mean? It means it only has two elements. So the hydrogen has to be one element. So we're talking about hydrogen and just one other element. These acids are some of the common ones. At least I know one of them should be pretty common that you've heard about. So let's look at it. If it's a binary acid, and we know it's coming from this H+, so we're looking at it in negative, it has to be an anion. Well, these are my anions. These are just the single elements. So these are when chlorine turns into chloride, sulfur into sulfide. These are the anions I'm looking at, your monoatomic ions, one atom ions. So what happens? This "ide" name is going to change, and also we add the word hydro in front of it. These are the only acids that have hydro. Write yourself a note to the side or something. Only ones with hydro. Okay, so here's some example. And again, what's going to happen? Look at the "ide." The "ine" turns to an "ic", and then it's an acid. So what does that mean? Well, this is the chloride ion. When chloride ion is partnered with the hydrogen, and what happens is it's not the hydrogen chloride gas. This means we've bubbled it, dissolved it in water. That's what the aqueous means, that it's been dissolved in water. What happens? We get hydrochloric acid. This is the acid that's in the swimming pool. This is in the acid that's in pretty much stomach acid. Okay, same thing here. Sulfide, what's my formula? Hydrosulfuric acid. So this "ide" turns to "ic" acid because it's binary. We have a hydro in front of it. Okay, when we write those formulas, because remember it's an H+, so you're still balancing the ions. So since this is a -1, whatever the charge is, that's how many hydrogens you need to balance it out. Charge is 1, 1 hydrogen, HCl. Charge is 2, 2 hydrogens to balance it out, H2S. These are binary acids. Okay, then if it's not binary, what are we talking about? Oxyacids. Oxyacid has hydrogens, and there's one more compound, and your oxygens. Or if you look at it, where they're going to have with it a polyatomic ion. That's what we're looking at, is that polyatomic ion. Well, this is where you're going to need your periodic table out and have it on that back side to be looking at those ions, because the name of the ion dictates the name of the acid. So look what we have. If it ends in an ite, we turn it to an OUS acid. So sulfite becomes sulfurous acid. Same thing. How do I know I had two hydrogens with it? Because I had a charge of -2. That's how I have my two hydrogens. Nitrite becomes nitrous acid. -1, one hydrogen to balance it out. Okay, what do I know my names, my other polyatomic ions end in? I have ites, I have eights. So if it ends in an 8, then it changes to an ic acid. So compared here, this was the sulfite, becomes sulfurous. But this is my sulfate ion. It becomes sulfuric acid. This is my nitrate ion. It becomes nitric acid. So let's just kind of do some practice here. We're going to go back and forth from this. So here's the anion. What anion is this? This is iodide. So what's the formula? Well, -1 charge. Formula. Hi! Did I wake you up? Okay. What's your formula? HI. Okay, what's the name of it? It's a binary. If it's a binary, hydro iodic acid. Iodide turns to an ic. Hydro, because it's binary, hydro iodic acid. Okay, let's look at this one. Let's break it apart then. So we know it's an acid because it has the hydrogen. So right here's my anion. What is that ion? Anion, PO4 with that -3 charge. Look it on your chart. What is that called? That's called phosphate. It's an 8. So what becomes to 8s? They become X. Now this is one, just to make it, it actually becomes phosphoric, excuse me, let me get that, phosphoric acid. This is in your sodas, Coca-Cola especially. You have phosphoric acids added to make it a little bit tangy into the formula. Okay, let's look at these. What was this ion? Find it on your periodic table. Find it on the back of the periodic table. What is this? This is the acetate ion. Again, that's what's focusing it. So what's the formula? Charges 1. You have 1 hydrogen, C2H3O2. It's an 8. 8s become X. So this would become acetic acid. So we're just going back and forth. You have to look at the name of the ions. The name of the ions helps you to know the formula, but the name of the ions, more importantly, helps you to know how to name it. Okay, I'm leaving the rest for you, and we'll come back and look at this tomorrow, but I want you to fill out the rest of this chart. Yes, there's going to be a stamp. I'm going to be looking at this, and I'm going to be stamping and looking at it, but beyond just the stamp, I'll find the cute one, you need to know how to name these. They're going to be on the test. I would expect to see a couple acids on the test on Tuesday. So practice it, fill out the chart. It's not that hard, but you do realize you're not going to have this in front of you in front of the test. So there's a few of these things that you need to maybe get to where you're covering up this top part and trying to name it without, and then kind of going back and double check so you can see how it goes. So I want you to finish the rest of this. It's a short podcast, so you have time. You can finish the rest of this. 15 minutes of homework. I don't think I'm asking for too much. I'll see you tomorrow.